Okay, so today we're going to talk about trig ratios, and I'm having to do this on my phone, so we're going to see how this goes. So let's start off with trig ratios. We have done this before. Well, you have back in geometry. So this is supposed to be a review, so I'm going to go really quick because I have limited time to make this video. So here we go. So trig ratios, do you remember SOHCAHTOA? Where you use this with right triangle trig. And this is the only time you can use SOHCAHTOA with right triangles. Okay, sine is pronounced sine, not sin. Even though when we abbreviate it, it looks like sin. You don't want to say sin because then it sounds silly. It's sine. The next is cosine, and it is abbreviated as COS. Then tangent, and we say tan sometimes, and it's TAN. So we've talked about the Greek letters pronounced theta, and it's for an unknown angle. So if we start off with this, it depends on our perspective. Then what if we're looking at sine, cosine, and tangent for our opposite and our adjacent? So if our theta is right there, your theta is, or your opposite is across from your theta. Remember, your hypotenuse is always going to be across from your right angle. That will never change depending on where your theta is, if it's at the bottom left angle or if it's at the top right angle. Your hypotenuse is always going to be the same. And then your adjacent is going to touch the angle that you're looking for. So let's say that our theta, let's do another one. Let's say that we're looking for, let's say this becomes our theta. So therefore our perspective changes. So no longer is this going to be our adjacent, but it's going to be our opposite. And then right next to it, the one it touches, it's going to be between my hypotenuse and my adjacent side. So remember, sine is opposite leg over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Next, so when we're finding cosine, tangent, sine, cosine, and tangent, we're just writing a ratio. So let's look at this problem. So if we're looking at our perspective is this theta right here, we've shrunk ourselves down, and shrink yourself down, that's where man's waving, is for you to put yourself into that angle. So you're looking at it from that perspective. So if you're looking at it, across from it is going to be your hypotenuse. Sorry, your opposite. I wrote opposite and said hypotenuse. And then across from your right angle will be your hypotenuse. And then next to it is your adjacent. So if we were looking at this and we wanted to know sine, we're going to look for your sine of theta is going to be your opposite, which we said is 35, over your hypotenuse of 37. Now, if you could simplify these, you want to, but in this case we cannot, so we're not going to. So cosine of theta is equal to your adjacent, which is 12, over your hypotenuse, which we said is 37. So far, so good. Tangent is going to be the opposite. So our opposite we said was 35. I need to write this better. This needs to be tangent of theta is equal to 35 over our adjacent, which is 12. And there we have it. Next. Okay, so now let's look at this one. We're given a triangle, ACM. We're given two sides, but we don't know our third side. So we must use the Pythagorean theorem that states a squared plus b squared equals c squared. So we know one side is 2. So we can say 2 squared plus we don't know what the other side is, the other leg, but we do know what our hypotenuse is a. So remember, it's leg squared plus leg squared equals hypotenuse squared. So we have 4 plus b squared equals 25 squared. Then we must subtract our 4 over to the other side. These 4's cancel. So b squared is equal to 25 minus 4 is 21. Square root both sides, so we can just get b. So b is equal to square root of 21. So if we could simplify that, if there was any perfect squares in there, we would want to go ahead and get rid of or simplify it even more, but we can't. So this tells us that this side is square root of 21. So now it's asking us, so sine of A. So the perspective of A, so A right here is going to be theta. So if we do across would be our opposite, this would be our adjacent, and of course 5 is going to be your hypotenuse. So now we have everything we need to know to set up our ratios. So here we go. So let's start with number 1. Sine of A is going to be opposite, which is 2 over your hypotenuse of 5. Cosine is going to be your adjacent, and we said our adjacent was 21. Square root of 21 over 5. So that's our answer. And then tangent says our opposite, which is 2, over our adjacent, which is 21. So the problem here is we're not allowed to have a square root in our denominator. So that means we have to rationalize the denominator. And to do that, we multiply square root of 21 times square root of 21 on the top and the denominator. Because the square root of 21 times the square root of 21 is equal to the square root of 144. No, it's not. It's a huge number. I don't know what it is off the top of my head. But I know that it's going to equal 21. Just like square root of 2 times square root of 2, square root of 4, square root of 4 is 2. So we know that. And then if we multiply these straight across, we get 2 square root of 21. Now, I would try to simplify 2 and 21 if I can, but I cannot, so we are done. Okay, I'm going to skip number 4 for now. We will talk about that when we're all together, but it just is going to be confusing if we kind of try to talk about it now. So next, here's just a chart of how you can remember your SOHCAHTOA. All right, next we're going to find missing angles and side. So when we're finding a missing angle, we have to use the inverse button. So you must have your calculators to do this. If you do not have calculators, you can use a graphing calculator, you can use a scientific calculator. You just need a calculator with a sine button and then the inverse of those. So you need sine, cosine, and tangent, and then typically on top of it, on like above the button, it will say like sine of the inverse of negative, or the sine of -1 as an exponent, and cosine of -1. That means inverse. All right, we'll come back to this later, but we are going to focus on this one right now. When we're trying to find an angle, we use the inverse. So we're going to have to do inverse sine, cosine, and the tangent, the inverses of those. All right. So let's find out, we need to find out x, and it says round to the nearest 10. So don't forget to look at that. So again, we want to shrink ourselves down, and we want to identify first which one's the hypotenuse, which is this, what your opposite is, which is this one, and then this is your adjacent. So to figure out what is it asking us for? Tan of theta. So we want to know what that theta is. So right now, let's see if I can get out of here. We know that tan of theta is equal to the opposite over your adjacent. So, and we've been given our opposite over adjacent. So we can say that tan of theta is equal to, well, let's find out what the opposite is. The opposite is 20 over your adjacent of 40. So that's 20 over 40. So right here, we can't just go and plug this in. We have to do something to it. So we have to kind of get tangent to the other side of the equation so we can isolate theta. So we want theta by itself. Well, to get a trig function to the other side, we have to do the inverse of it. So essentially what we're going to be doing is we're going to be multiplying this by the inverse of tangent to both sides. Because what happens is the inverse of tangent times tangent actually cancel out, and then you're just left with theta. So then we have theta equals, well, we have to put our inverse tan right here, times 20 over 40. Okay, so get out your calculators because at this point, this is calculator work. So we have to put in calculator. So we're about to do that. I think I have a slide over here. So the first thing that you have to do is you have to be in degree mode. And to be in degree mode, you're going to go to mode. So everybody go to mode. And you want to scroll over. Typically, it's already going to be in radians. It's going to be in radians. It's going to have it bolded in radians. Well, you want to change that so that it is bolded in degrees. So if you do that, go ahead and do that because we can't move on unless you do it. So I'm going to go make sure mine is in degrees. So I'm going to mode and mine is already in degrees. Okay, so here's a test to make sure that you're in degrees. I want you to go and press sign. So do you see all of your sign buttons down here? Go and press sign and then plug in 90. Because I know the sine of 90 should equal 1. So if your calculators, if you get sine of 90 equals 1, then you're in degrees. If you get sine of 90 is equal to 0.89 blah, 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 some crazy decimal, then you're still in radians. Okay, so now go and press. Now we need to find the inverse tan. The inverse tan, let me squeeze in here. It is right here. So you're going to have to go second tangent, second tan, and then you're going to type in 20 over 40, and we should get this number. So go ahead, I'm going to give you a second to do that. Now the direction's set to round to the nearest tenth. So if we look at this, then that means that we would have to round to 26.6 degrees. Don't forget to put your degrees. So theta is equal to 26.6. And that is our answer to the other problem. Go back. So then we know that theta is equal to 26.6. And you know, we should really, instead of equals, we should put approximately equals to 26.6. All right, guys, moving on. So you're going to have to do this in your calculator because I don't have this calculator done every time. All right, here we go. Let's do maybe one or two more of these and let's move on. Okay, so now if we're doing sine, again, if you're looking at x, this is going to be your opposite. This is going to be your hypotenuse. Sine says sine of theta equals your opposite, which is 15 over 50. So now remember, we want to isolate theta. So we're going to have to multiply by inverse of sine to both sides. As these cancel, and then we're left with theta equals inverse sine of 15 over 50. So go ahead and do that in your calculator. Inverse sine of 15 divided by 50. And what I got was theta is approximately 17 point, and I got 45. And does it say to round to the nearest tenth? So that means 1 decimal place. So I have to round that 4, 5 up to just 5. So then this is going to be theta is approximately 17.5 degrees. Done. Okay. Let's see. Okay, we've got one more. We'll just do it in the, for cosine. Same thing. We're going to have cosine of theta equals, now this time it's going to be adjacent over hypotenuse, so 7 over 23. And so we're going to have theta equals the inverse cosine of 7 over 23. 7 divided by 23. I'm going to my calculator to work this out. So I got 72.28, and this said round to the nearest degree. So 72.28 degrees, but then it said to round. So to the nearest degree, so this would be approximately 72 degrees. So you have to make sure to read your instructions on what it wants you to round to. See, round to the nearest degree. All right, so now what if we're missing a side? So let's try some of these. So if we're missing a side this time, we need to find our x. So again, you're looking at your perspective and you're trying to figure out what trig functions you're going to need to use. So in this one, we are given our adjacent side, and then we're looking for our opposite side. So what trig function do we need that has opposite and adjacent in there? The only one that does is tangent. So you have tan theta, I'm just going to write it down, is opposite over adjacent. So we now know what theta is. Theta is 55 this time. So tan, it is acting up. So tan of 55 degrees is equal to our opposite, which is x, over our adjacent, which is 20. So now we need to get x by itself. So to do that, we're going to multiply to 20 on both sides. So those 20s cancel. So we have 20 times tangent of 55 degrees. All right, so in our calculator, we're going to type this in just as is. You're going to push 20 to 0, and then you're going to go to the tan button, not the inverse, just a tangent, and say 55. And then I got x is equal to, does it tell us to round to the nearest something? It says to the nearest 10th. So I got 28.56. So that means I'm going to round this to 28.6. Okay, and did they give us links on here? So yes, this should be approximately, and the units of measure is meters. So here we go, 28.6 meters. Done. All right, next. Okay, so find the missing side, round to the nearest 10th. So this time we're given opposite and adjacent again. So I just put tan because that's what we're going to have to use. So we're going to have tan of 72 is equal to the opposite, which is 80, over the adjacent. So this time our variable is in the denominator. So we can multiply this by x to both sides, and we can get this to be x tan of 72 is equal to 80. Well, x is still not by itself, so then we're going to have to divide by 72, tan of 72. So those cancel, and we're left with x equals 80 over tan of 72. Again, plug it into your calculator, and you'll get to see that when it looks like this, where x is on the bottom, it's always going to be that x and tangent of 72 just switch places. So you can kind of just remember that and not have to go through all the work every time. So we get x is equal to, and it says to round to the nearest tenth again, I got 25.99, which means this is going to be approximately 26 feet. And then we're done. Okay, so do you see what I mean where they just really just switch kind of sides? They just switch places. So that 72 would become x, and then the tan of 72 goes where x is. All right, this one is going to be a sine, and I think I'll just set it up for you because I think you guys would be able to, I mean, it's the same thing that we've been doing, except this time it's going to be sine. So because we're given opposite over hypotenuse, we have sine of 24 degrees is equal to your opposite is x over 283, which means we have to multiply 283 to both sides. So then we're left with x equals approximately, okay, and go ahead and put that in your calculator, 283 sine of 24, and we get 115.1 meters. And we're done. This one, if you want to do this, this would be cosine. So you would have cosine of 40 equals x over 20. And then you end up getting, if you want to try this one on your own, I got x is approximately 15.3 feet. So you can try that one on your own if you want to. So remember, this is something that you might want to write down on the back of your unit circle. So when you're trying to find a side, we use sine, cosine, tangent, just our regular old sine, cosine, tangent buttons on our calculator. However, when we're trying to find an angle, we're going to use the inverse sine, the inverse of cosine, and the inverse of tangent buttons. All right, guys, I gave you an assignment that had circled problems.